Hey there everyone. I think this is the last of our review videos for our calculus prerequisite projects. Here we go. Rational functions. So this is something you would have first encountered in our Math 3 course. You may remember it well. The key thing to know about rational functions is that they are a ratio, hence rational, of polynomial functions. So both the top and the bottom, numerator and denominator, need to be need to be polynomials. Just be careful though, anytime we have a ratio, you want to be mindful of the fact that the denominator should not be zero, right? So we're going to be finding out what those zeros are and helping to use that information to graph these things. So knowing the domain of a rational function is fairly simple. You just need to consider when your denominator is going to be 0 and then go from there. So there's really good examples in our textbook, so I would encourage you to just sort of flip through this. Don't rely only on this video. They'll use charts of numbers to help us understand both the horizontal and vertical asymptotes. So for you guys, you want to be really clear the difference between what we call limits or asymptotes out at infinity. That's when x gets very large, positive, or very large, negative, or asymptotes as they approach a certain number. That's when the x value will be approaching a number that gives you a 0 in the denominator. Those are the vertical asymptotes. So we have horizontal and vertical asymptotes. So our textbook really is very good. So please take the time to look through this. I will not just sort of reread what is in the textbook. Part of what we're hoping you guys get out of having a textbook is the ability to read and process that information. It's still incredibly useful when you guys go to college. You're going to need to be able to have good textbook reading skills. So I invite you to go through this and really look at what this notation is, become comfortable with it. It's very sensible. Mathematicians like having the notation be sensible. So as f of x gets closer to infinity, or as f of x gets closer to negative infinity, that's what we're talking about in terms of a vertical asymptote. What is going to drive it there is an x value that gets close to making 0 happen in the denominator. Okay, so here now it's when x goes towards infinity, or when x goes to negative infinity, that's when the function value will be driven towards a horizontal limit or boundary. That'll be a horizontal asymptote. Okay, so they have examples of this, and then they talk through sort of how you can decide what those vertical or horizontal asymptotes are. They give a couple of good examples, okay? In part A here, you can just see that denominator, you're going to get a 0 whenever x is positive or negative 1, okay? Because you'll square it, it'll become positive, and then when you subtract 1, you get 0. So x cannot be positive or negative. There are the vertical asymptotes there. So you've seen these graphs before. This should be right in your wheelhouse. When you are able to cancel things, you'll get holes that can be removed, and it might simplify things down. So don't think that automatically you get an asymptote wherever there's a 0. Sometimes those are the removable discontinuities. All right? So here, know these guidelines. There will be relatively few times where we will be graphing these, but there'll be many times where we're talking about asymptotic behavior. Okay? So again, calculators can help. And here they have a few key examples. I like the real world example that they use down here to talk about how, whoops, I'm getting close to it. Oh yes, we will not be dealing really with anything that has to do with slant asymptotes. There are times where we're dividing things out and we're getting rational functions simplified, but that is not here. Applications. I like this little cost benefit model that uses sort of asymptotic understanding that it gets more and more difficult to remove pollutants. If you're trying to remove absolutely 100% of your pollutants, the cost will be super high. But that's the asymptote you can approach. You could never remove more than 100%. So of course, as you strive to get to that goal, the cost would go up. Anyway, look over that chapter. Hopefully that'll make sense. Good luck.